welcome to this video on transforming graphs. Now this is an A-star subject, so it is very difficult, but we are going to start right at the basics, and I'm going to take you every step of the way through this. Now first of all, we need to get used to function notation. Now here it says y equals fx. What that means is that y is a function of x. So f is a rule for working out values of y using x. This function could be anything involving x. It could be x squared, it could be cos x, it could be x squared plus 2x plus 3. There are lots of different options of what it could be. Now, we use function notation to describe when we make changes to it. Now, the first two changes I'm going to look at are adding numbers or taking numbers away from this function. Now here you can say y equals fx plus a. Now that is a change that I've made to my function. I've added a after the function. Now the way this is going to change the graph is it's going to change the y values. So it's going to be changing it in the up and down direction. It will be parallel to the y-axis when it's changed. And the second one, y equals f of x plus a, that means I've changed the x values too. It's going to change it in the left and right way. But instead of adding a to all of my x values, it's actually taken away a, so the opposite sign of whatever it is. So again, now changing the left, right way, and it'll be the opposite of what it says has happened to the function. Now I'm going to show you a couple of examples of what that means so you get a better idea of this. So let's say y equals f of x, and this is y equals x squared. So that's my function, that's my graph here. What I'm going to do is I'm going to first just sketch y equals f of x plus 3. Now the plus 3 has happened outside of the brackets, it's affected my y values. So my y coordinates are going to go up 3, they're going to increase by 3. So instead of crossing at the origin, it's going to cross the y-axis here at 3. And every value is going to go up by 3. So it's going to look just as a sketch like this. It's been shifted up by 3. Similarly, for part B, it's outside the brackets, it's y equals f of x, take away 4, so all of my y value is going to go down 4. So every single one of those y values is going to go down by 4. My graph is going to move down by 4. And again, this is just a sketch, just showing those important places where the graph is moved down by 4. Now for C and D, my transformation of the graph has happened inside the brackets. So it's affecting the x values, it's going to be affecting it parallel to the x-axis, so left and right. But it's also going to do the opposite of what I expect. So here, f of x plus 2 is actually going to take away 2 from all of my x values. So my graph is going to shift to the left by 2. And my graph is going to look like this. So shifted to the left to have taken away 2. It does the opposite of what you expect when it affects the x values. And here, part D, y equals f of x minus 1 is going to be shifted by 1 to the right. I'm going to add 1 to all of my y values. And that graph is going to look like this. So if it's outside of the brackets, it affects the y values. If it's inside the brackets, it affects the x values, and it does the opposite of what you expect. So here, different function this time, y equals x cubed. If I was going to plot y equals f of x plus 3, that's going to add 3 to all of my y values. So this graph is now going to look something like that. It's not a particularly good sketch, but I've got the important places that it crosses. It's gone up by 3. The second one, y equals f of x minus 1, when I draw that, it's going to be affecting the x values, but it does the opposite of what I expect. So every x value is going to be shifted over by 1. So it's going to be moving to the right one. I've added 1 to it. Where's the coordinates of the point 0, 0 going to be mapped to? Here 0, 0 Now the other two ways we can transform graphs is if we multiply f of x by something. That number can be either outside of the brackets, in which case it will multiply all the y values, or if it's inside the brackets, it will affect the x values. But again, it will do the opposite of what we expect. This time it will divide the x values by that number, it will not multiply them. So, for example, if we had this picture here, this graph, and this is f of x, f of 2x, so again, that's inside the brackets, it's going to affect the x values, but it does the opposite of what I expect. So all of my x values get halved. So instead of this minimum point being at 2, it's actually going to be at 1. And instead of this point here being at 4, it's going to be at 2. The 0 point will actually stay at 0, because 0 divided by 2 is still 0. So what we will get is something that's being shrunk by, it has been halved, it has been divided by 2. Another question for an example. This time, my function, I'm now going to be plotting y equals 4 times by f of x. So this is outside the brackets, it's going to affect the y values, and it's going to do what we expected. It's going to multiply all of them by 4. So all of these numbers are going to be multiplied by 4. So actually, for example, this point is going to be times by 4, is going to be moving up by 4. All of the values are going to be moving up. So my sketch is going to look like this. It looks like it's kind of been stretched out upwards. It's been expanded, it's been multiplied by 4. And the origin is going to stay where it is, because 0 times by 4 is 0. One more example, a graph you may or may not have seen. This is cos x. So cos x looks like this, it's kind of a squiggly line. And this shows it a lot better when we're stretching or squishing our graphs. So if I wanted to draw y equals 2 times by f of x, which is just 2 cos x, that means I'm going to be affecting my y values because it's outside of the brackets, and they're all going to be multiplied by 2. So 1's going to go to 2, minus 1's going to go to minus 2. And that's going to be the same for all of these points here. And where it's 0, it's going to stay at 0, because 2 times by 0 is still 0. So it's been stretched out by a factor of 2. If I was going to draw y equals f of 2x, which is cos of 2x, again it does the opposite of what we expect. So all the x values are going to be halved. So this minimum point at 180 is now going to be at 90. This maximum point at 360 is going to actually be at 180. This minimum point at 540 is actually going to be at 270. This maximum point at 720 is actually going to be at 360. So our graph is going to look like this, and if we carry it over. So, to recap what we've been talking about, if the number is outside the brackets, it affects the y values. If it's inside the brackets, it affects the x values. But whenever it affects the